When you look up at the night sky, it's easy to feel like you're seeing all there is to see. Twinkling stars, planets, and the occasional satellite drifting across the darkness. But what you're really seeing is just the tip of the cosmic iceberg. For every bit of matter in the universe that we can see, there's an equal amount that's invisible, a mysterious substance called dark matter. And even stranger, 80% of the stuff out there isn't even that. It's a force called dark energy, which makes up a whopping 95% of the universe. All of this invisible stuff is held together by gravity, the same force that keeps your feet on the ground. But when scientists try to measure the strength of that gravitational pull, they get a result that doesn't make any sense. It's as if the universe is conspiring to hide its own weight. And that's not good, because figuring out how gravity works on the largest scales possible is kind of crucial to understanding how the universe works. Our first clue that something was amiss came in the 1930s when the astronomer Fritz Zwicky noticed that galaxies in the Coma cluster were orbiting around something that was not there. He could tell because he could see the effect of the missing mass's gravity on the galaxies. It was like watching a game of celestial chicken. The galaxies were playing a high-stakes game of gravitational chicken with an invisible Grand Canyon, but there was no way they could win because there wasn't enough mass in the cluster for gravity to have that much pull. So to make the math work, Zwicky hypothesized that there must be some sort of invisible matter in the cluster that was providing the extra gravitational oomph. He dubbed this mysterious substance dark matter. Dark matter is an idea that's stuck around for a few reasons. For one, scientists have seen this mysterious stuff indirectly many times since Zwicky's day, usually by observing its gravitational effects on things we can see, like stars and galaxies. Also, astronomers have been able to map the distribution of dark matter in the universe by measuring tiny variations in the cosmic microwave background, the afterglow of the Big Bang. These observations have given us a pretty detailed picture of the matter around us, which looks a lot like the matter that makes up everyday objects, except for the fact that we can't see it or interact with it in any way. That makes dark matter one of the least friendly neighborhood of matter out there. But here's the thing. All that evidence for dark matter still leaves us without an actual idea of what dark matter is. One popular idea is that it's made of some exotic particle that we haven't detected yet. But scientists have also put a lot of effort into finding those particles without success. So far, they've ruled out more than half of the possible dark matter candidates, which means they need to start thinking of some new ones. Meanwhile, the other 5% of the universe's missing mass is made of something called dark energy. Unlike dark matter, dark energy was a total surprise. In the 1990s, scientists were trying to figure out whether the expansion of the universe was speeding up or slowing down. They expected that the expansion would slow down due to the gravitational effects of all the matter in the universe. But much to their surprise, they found that the expansion was actually speeding up. There was something out there repelling the galaxies, pushing them apart faster and faster. Scientists have no idea what this repulsive force is, but they gave it a catchy name, dark energy. And the problem is that while we know that dark energy exists, we don't know anything else about it. We don't even know if it's a force or if it's something else entirely. One possibility is that it's a kind of anti-gravity that's turned the whole universe into a sort of cosmic trampoline. As the stuff that makes up the universe falls towards each other, drawn together by regular gravity, dark energy bounces everything back away from each other, keeping them from ever collapsing. The race is on to figure out what dark energy is and how it works, which will be super helpful once we figure out how to control it. Because all of this invisible stuff makes up 95% of the universe, it has a gravitational pull that affects everything we see. That means that to understand the universe, we have to understand dark matter and dark energy. Luckily, there are plenty of experiments searching for dark matter and missions mapping the distribution of dark energy in space. Hopefully, we'll get some answers soon. Because while dark matter and dark energy might sound like a couple of party-pooping buzzkills, having a complete picture of the universe would be the ultimate party.